This is SpaceTime, Series 24, Episode 87. Coming up on SpaceTime, small impacts churning up Europa's surface, making the search for life more difficult. ExoMars fails to detect any Martian biomarkers of life. And China tests a new suborbital spaceplane. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims small comet and meteoroid impacts on the Jovian ice moon Europa will make the search for evidence of signs of life beyond Earth far more difficult. Over billions of years, Europa has experienced a battering of impacts. And as the surface of the icy moon churns, material brought up to the surface is zapped by high-energy electron radiation accelerated by Jupiter. Scientists have been studying the likely effects of all these small impacts on Europa's surface as they prepare to explore this distant moon with NASA's upcoming Europa Clipper mission and to look at the possibility of a future lander mission. Europa is of special interest to science because of its subsurface global ocean which lies beneath its thick ice crust. This massive body of water, at least 3 times more than the Earth's oceans combined, may have conditions suitable for life. And there's growing speculation that some of this water could be seeping out onto the surface. So what's the likely effect of the accumulation of all these impacts from comets and meteors onto the Jovian moon's surface? Well, a new study in the journal Nature Astronomy has been calculating just how far down this churning process, called impact gardening, may have disturbed Europa's frozen crust. The study estimates that the surface of Europa has been churned by small impacts to an average depth of around 30 centimetres. And any molecules that might qualify as potential biosignatures, which includes chemical signs of life, could be affected at that depth. That's because the impacts would churn material up to the surface where radiation could break down the bonds of any potential large, delicate molecules generated by biology. Meanwhile, some material already on the surface would be pushed further downwards, where it could be mixed with the subsurface, further contaminating the scene. The study's lead author, Emily Costello from the University of Hawaii, says finding pristine chemical biosignatures would require looking deep below this impact gardening zone, because chemical biosignatures in areas shallower than this zone may have been exposed to destructive radiation. NASA's Europa Clipper mission is slated to launch in 2024, undertaking a series of close flybys of Europa as it orbits Jupiter, carrying instruments to survey the moon and collect samples of dust and gases kicked up above the surface. This is SpaceTime. Still to come, ExoMars fails to detect any Martian biomarkers, and China tests a new suborbital spaceplane. All that and more still to come on SpaceTime. The joint European Space Agency Roscosmos ExoMars Trace Gas Orbiter mission has failed to detect any chemical biomarkers, potential signatures of life, in the Martian atmosphere. There were 4 specific biomarker chemical signatures it was searching for: methane, ethane, ethylene, and phosphine. Methane's a biomarker of special interest on the red planet because while it can be produced by geological processes, it's also produced by biological activity, at least on Earth, and the same could be true on Mars. The Martian methane mystery has been ongoing for many years now. Ground-based telescopes on Earth, as well as ESA's Mars Express orbiter and NASA's Mars Curiosity rover on the surface of the red planet, have all captured sporadic spikes and bursts of methane gas in the Martian atmosphere. Fluctuations in the amount of methane gas present seems to vary with the seasons and even the time of day. Previous estimates from Mars Express and ground-based missions range from 0.2 up to 30 parts per billion by volume. That means 30 molecules of methane for every billion molecules in the Martian atmosphere. Now, by comparison, methane present in Earth's atmosphere is around 2,000 parts per billion by volume. However, the Mars Trace Gas Orbiter spacecraft has failed to detect any methane. A study published just a few weeks ago suggests that's because the Mars Trace Gas Orbiter has been monitoring during the daytime, and it's been monitoring the air a few kilometres above the surface, where and when any surface methane concentrations would have been dispersed by local breezes and turbulence caused by the sun warming the air. At the same time, NASA's Mars Curiosity rover has detected methane at the surface with higher nighttime concentrations and lower concentrations during daytime readings. Trace Gas Orbiters also looked for two other potential biomarker gases in the Martian atmosphere, ethane and ethylene. These molecules are expected to occur after methane is broken down by sunlight. But like methane, both have relatively short lifetimes, meaning that if they were found in the planetary atmosphere, they would have been only recently created or released through some ongoing process. But again, Trace Gas Orbiter failed to detect any sign of either molecule. Finally, the orbiter's also been hunting for phosphine. That's the gas which caused the stir last year when one team of scientists thought they detected it in the atmosphere of Venus, only to be contradicted months later by another team. Most phosphine in Earth is biologically produced, making it an exciting biomarker in the atmosphere of terrestrial worlds. But once again, Mars Trace Gas Orbiter failed to detect any sign of it. The upcoming ExoMars rover Rosalind Franklin, which will launch for the Red Planet in 2022, will complement Trace Gas Orbiter's hunt for biomarkers by digging down into the Martian soil, in the hope that underground samples may be more likely to retain biomarkers, as the material there is shielded from the harsh radiation environment of the surface. This is SpaceTime. Still to come, China tests a new suborbital spaceplane, and SpaceX launches 88 satellites, including 2 space tugs. All that and more still to come on SpaceTime. China says it's tested a prototype of a new reusable suborbital spaceplane. Beijing claims the unmanned prototype was launched aboard a carrier rocket from the Jiuquan Satellite Launch Center in northern China's Inner Mongolia. After separating from its launcher, Beijing claims the prototype flew some 800 kilometers, undertaking a conventional runway landing at the Al-Asar Right Banner Bandandalin Airport in southwestern Inner Mongolia. No other details of the clandestine flight have been released. And there's growing speculation the announcement was designed to take attention off Richard Branson's Spaceship Two test flight in New Mexico, with those behind the Chinese announcement claiming their spaceplane could carry space tourists to 100 kilometers above the Earth, fly people on ultra-fast intercontinental journeys, place small satellites into low Earth orbit, and even help in space station operations by transporting crew members and material between the station and Earth. This is SpaceTime. Still to come, SpaceX launches 88 satellites, including 2 space tugs, into orbit. And how hard is it to take those stunning astronomy images? All that and more still to come on SpaceTime. SpaceX has successfully launched its Transporter 2 rideshare mission with a Falcon 9 rocket carrying 88 small satellites into orbit. The flight blasted off from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida. It had been delayed by a day because of unauthorized aircraft in the launch area.
6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
Vehicles pitching downrange.
First stage chamber pressure is nominal.
We are T plus 42 seconds into flight. Falcon 9 has cleared its tower, and we're currently throttling down in preparation for max Q. That should be coming up in about 20 seconds. Max Q is where the vehicle will experience the highest amount of aerodynamic pressures.
Falcon 9 is supersonic. Max Q.
And you heard the call out. We've passed the period of maximum aerodynamic pressure. Falcon 9 is now headed south along the Florida coast. All is looking good with the first stage trajectory. We have 5 events coming up in quick succession in about a minute. The first is main engine cutoff, also known as MECO, followed by stage separation, where the 2 stages will separate from one another. The first stage will then perform a flip to head back towards Florida. The MVAC engine on the second stage will form second engine start 1 and ignite that MVAC engine. Then the first stage will also begin its first of 3 burns, the boost back burn.
Stage separation confirmed.
We had successful stage separation. The first stage started performing its flip maneuver, and the boost back burn should be ending in about 25 seconds.
Stage 1 boost back shutdown.
And there was confirmation of a successful boost back burn. Again, that is the first of 3 burns for the first stage. Coming up next is fairing deploy in a few seconds here from the top of the second stage.
Fairing separation confirmed.
And off come the 2 fairing halves, and they have separated and fallen away from the vehicle, exposing the 88 spacecraft to the vacuum of space. As a reminder, the recovery vessel HOS Briarwood will be attempting to recover the fairing halves today from the water. So we are about T plus 4 minutes and 20 seconds into flight of our second stage Merlin vacuum engine, also known as the MVAC engine. It's currently in the first of 2 MVAC burns. This burn should last for until the T plus 8 minute and 24 second mark, about another 4 minutes left on this burn. And the next milestone will be for the first stage to perform its entry burn. Falcon 9 needs to execute an entry burn to slow itself down before hitting the dense parts of the atmosphere. And without this burn, relying on the atmosphere alone to slow Falcon 9 down would put unnecessary strain on the rocket.
Vehicle is on a nominal trajectory.
The call out for a nominal trajectory. Everything's looking great so far on the Transporter 2 mission. Honeycomb-like structures have deployed on the first stage. Those are our 4 hypersonic grid fins positioned at the base of the inner stage. They help to orient the rocket during reentry by moving the center of pressure. There's also some plumes of gas coming out. This is cold nitrogen gas, which helps with attitude control. Both are essential to make sure that we have a nice targeted landing back on landing zone 1 later on in today's mission. The second burn, the entry burn, is coming up in about 30 seconds. Shortly after the entry burn ends, we'll hit the denser parts of the atmosphere and also begin to further reduce our velocity as the first stage continues to make its way back towards Earth.
Stage 2 FTS is saved. Stage 1 entry burn startup.
There's the call out. 3 Merlin engines have relit and are currently slowing down the first stage. This burn is expected to last for another 15 seconds or so.
Vehicle on a nominal trajectory. Stage 1 entry burn shutdown.
And successful completion of our second of 3 burns. As I mentioned earlier, we are going to be attempting to recover the booster for an 8th time back on land at landing zone 1. The first stage has 1 more burn left, the landing burn. It begins just before we touch down and provides the booster with a soft descent before we land. At the same time Falcon lands, we are expecting sequel 1 of our second stage. That's second engine cutoff. And shortly after that, we'll be entering a coast phase. Florida coast and landing zone 1 are approaching. This booster makes its attempt to land for an 8th time. The first stage coming down with its landing burn.
Stage 2 internal guidance. Stage 1, landing leg deploy.
That was as smooth as through the landing burn. You heard the sonic booms. This booster has landed for the 8th time. That is the 89th recovery of an orbital class rocket.
Stage 1 nominal landing confirmed.
And what a way to start off the Transporter
insertion.
2 mission. At the same time, we did have successful second stage, second engine cutoff, and confirmation of a nominal orbital insertion.
All satellites were successfully deployed some 90 minutes after takeoff. The mission was also the 8th launch for the same Falcon 9 core stage, which then returned safely back to the ground, landing on one of the 2 landing zone pads at the Cape Canaveral Space Force Station 9 minutes after liftoff. The US Defense Department had 3 spacecraft aboard the flight, Mandrake 2, Lynx and Poet, which are designed to gather information on new laser communications technologies designed to communicate with orbiting spacecraft. Also aboard were numerous communication, navigation, Earth observation and scientific spacecraft, as well as 2 orbital transfer vehicles or space tugs developed by Seattle-based company Spaceflight, which were used to help some of the other satellites reach their intended orbits. One of these space tugs, the Sherpa Light 1, is the company's first all-electric propulsion orbital transfer vehicle. This is SpaceTime. Still to come, astrophotography for beginners, and later in the science report, Russia completes tests of its new generation S-500 Prometheus air defense missile system. All that and more still to come on SpaceTime. So, how hard really is it to snap those stunning astronomy images you see in astronomy magazines and online? Well, the answer is it does take time and a lot of skill. But you may be surprised to know just how easy and inexpensive astrophotography can be for beginners. Jonathan Alley, the editor of Australian Sky and Telescope magazine, says you really don't need lots of expensive gear to get started.
We cover astrophotography in every issue of the magazine because it's a really popular thing to do, and it's so much easier these days with digital cameras than it was back in the old days.
It's a real reader base, isn't it?
Yeah, look, our reader base there are two kinds of readers we have. We have people who like to get out with their telescopes in the backyard and do lots of stuff, whether it's observing planets or stars or galaxies or whatever, or they like to take photos of them, or some of them even contribute to scientific programs. They actually gather data that the scientists can use. And we have other kind of readers who have traditionally been called armchair astronomers who just like to read about it, and that's fine too. So you've got sort of recreational astronomers, and then the term amateur astronomer probably should be used to indicate people who do a little bit of scientific stuff, perhaps. And then, of course, you've got the professional astronomers who do it for a living. But yeah, all sorts of people read Australian Sky and Tel, and it's a sort of topic that appeals to everybody, I think. Whether they want to get into it or not, everyone's got a fascination with the heavens. And astrophotography, as I say, it's so much easier these days than back in the days of film and chemicals and getting stuff developed and all that sort of stuff. Because you would take some photos on a roll of film, and then you'd have to get them developed somewhere somehow. And with astrophotography stuff, it wasn't always straightforward. And then days later, you worked out whether your photos came out or not. But now with digital cameras, you just see straight away. Yeah. It's just amazing. So anyway, what we cover this issue is making the most of what you have. If you've got simple gear, making the most of it. If you've just got a camera with a lens, what can you do with that? So we go all the way into that. So you don't need hugely expensive gear. You can go that way if you want to, but you don't need it. But you do need to learn to use your camera a little bit differently to how you would for daylight shots. So you're going to need to learn more about exposure times, ISO settings, aperture settings, shutter speeds, all that sort of stuff. You're probably also going to need to learn how to process your shots with some special software. It's not hard, but it just takes a little bit of practice, I guess. The good news is that there are lots of free programs out there that you can download that work with all the cameras and make it really easy to get the best out of your shot. So if the shot's looking a bit dull, you can brighten it up a little bit, for instance. There's all sorts of techniques you can use. We don't really go into it in this article.
Are all the programs very similar, or do they all have their own little features that put them above the next program?
Well, there are different programs that do different things. So, for instance, some people will take a series of photographs of the same thing and then stack them together. That can bring out more detail and more vibrancy in your photo and everything. So, but you've got to stack these photos together very, very carefully so that they all line up. So there are programs that will stack your photos for you. They'll spot some stars and make sure all those stars line up. And if those stars line up, then the whole thing will line up. Then there are other things that will, fiddle around with the colours in the pictures. If you do go to the extent of using filters and things on your camera, then there are programs that will work with the different photos taken for the different filters and then combine them into one picture that comes out as a nice, pretty colour picture. So there's all sorts of different ones. And as I say, a lot of them are free out there you can get, and that makes it a lot easier, of course. We don't go into it in this article as such, but we do mention it. If you're going to get into astrophotography, simple stuff with a tripod, for instance, then you're going to want to get yourself a good tripod, one that doesn't just wobble forever and ever and ever. If you just slightly bump it in the middle of the night, you want one that's really nice and steady. You can even get things called sky tracking platforms. So these are little devices that you can put on top of your tripod, and they're motorized, and you stick your camera on, and as the Earth turns, this tracking platform follows the turning of the Earth. So you don't end up, so you take a long exposure photograph and you don't end up with streaks or what they call trails. The stars don't trail and leave a line. They stay pinpoint sharp because you're continuing to focus on them as the Earth turns. So all sorts of things you can do that are fairly inexpensive, If you're going to take exposures of any duration, then you want to have a mount that tracks. And that means a mount that turns as the Earth turns. Otherwise, you are going to get pictures that are blurred. Not blurred because they're out of focus, but blurred because things are moving. The sky's moving and your thing's staying still. So, actually, the Earth is turning and the sky's staying still. So if you're going to take long exposure, then you want to get some sort of mounting system or tracking system that will move, such as this sky tracking platform I just mentioned. If you don't need to do that kind of thing, if you can just get away with the sort of pretty picture photography that's done in a few seconds, then you don't need to worry about the sky tracking. You don't need to do any of that sort of stuff. So you can just get yourself a good tripod. Now, you might also want to, if you've got a good digital SLR, you might want to get yourself a shutter release cable so that when you push down on when you take a photo button on your camera, that's when the camera shakes. That's when you can blur things. But if you get a shutter release cable, which you just click, if you imagine photographers in a studio, they've got these shutter release cables, that takes the vibration out of it. So yeah, lots of little things you can do. Look, if you want to get into astrophotography and you've just got a camera and the lens that came with it, then you can do really good stuff. Our article shows you how.
I'm surprised at how many really decent photos are taken by people just using their cell phone. It's shocking just how good some of them are.
Yeah, you can get really good results. You really can. You can hold your phone up to you can just use your camera to take photos of the night sky, pretty pictures. You can, even if you've got a telescope, you can hold your camera up to the eyepiece of a telescope and take some photos of the moon and that sort of thing. I've seen people do that. There are also attachments you can get that you can stick your camera on the side of your telescope, and it will track with the telescope and take some long exposure photos. And you can also get little lenses, extra lenses that you can put on the back of your camera the back of your phone where the camera is, and get yourself some extra magnification. So yeah, there's all sorts of options.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. A warm COVID-19 vaccine, one suitable for use in remote areas and resource-limited locations, may be a step closer following an international collaboration between scientists from India and Australia. The CSIRO has been evaluating heat-tolerant COVID-19 vaccine formulations developed by the Indian Institute of Science and biotech startup MindVax. The evaluation testing is being carried out against all current SARS-CoV-19 variants, including the Delta strain currently spreading globally. The findings, reported in the journal ACS Infectious Diseases, show the vaccine formulations are triggering strong immune response, providing protection from the virus while remaining stable at temperatures of 37 degrees Celsius for up to a month and 100 degrees Celsius for up to 90 minutes. And that's key, because most existing vaccines require refrigeration to remain effective, with Oxford AstraZeneca needing to be kept at between -2 and -8 degrees Celsius, and Pfizer requiring specialised cold storage at -70 degrees Celsius. A warm vaccine is crucial for remote and resource-limited locations, especially those with extremely hot climates lacking reliable cold storage supply chains. And that includes places like regional communities in outback Australia and island communities across the Indo-Pacific region. The World Health Organization now estimates over 8 million people have been killed by the COVID-19 coronavirus, with more than 4.15 million confirmed fatalities and some 193 million people infected since the deadly disease first spread out of Wuhan, China. A new study has found that the global risks of climate change and toxic pollution are strongly linked. The findings, reported in the journal PLOS One, show that countries most at risk of climate change impacts are also the ones facing the highest risk of toxic pollution. The results are based on a new data analysis of 176 countries. The countries identified as the most at risk included many of the poorest in the world, affirming previous research showing low-income countries face the highest risks of being affected by both climate change and pollution. When ranked against countries around the world, Australia and New Zealand had high ecosystem health and low vulnerability to climate change. Archaeologists have discovered a 3,100-year-old piece of jug bearing an alphabetic inscription. The ancient vessel was found at the Kirbet Araral dig site in Israel. The inscription says Jovian in alphabetic script and dates back to the time of the Old Testament's Book of Judges. It contains the Hebrew letters Yod, Resh, Bet, Ayin and Lamed, and remnants of other letters written in ink on a small personal pottery vessel that would have held about a litre of oil, perfume or medicine. The name Jovian was an alternative name for the judge Gideon ben Joash, who's reputed to have organised a small army of 300 soldiers to defeat the Midianites who had been crossing over the River Jordan into Judah and Israel to plunder local villages of their crops. The Russians have completed tests of their new generation S-500 Prometheus air defense missile system, which Moscow claims is capable of targeting stealth aircraft. The Russian military claim the new weapon is a completely new generation of anti-aircraft systems, capable of taking down medium-range and intercontinental ballistic missiles, as well as conventional, hypersonic and stealth aircraft. Russia's new weapons understood to engage targets at a range of between 5 and 600 kilometers. Last year, Moscow said the S-500 missile system, together with a new long-range early warning radar system, could enter service sometime this year following the completion of trials. Well, it seems the pseudoscience of astrology is making a comeback. Astrology is the belief that the gravitational influence of planets, stars, and even constellations light years away can somehow influence your personality and future events. Of course, there's never been any scientifically proven evidence supporting astrology. It's all based on a complete misunderstanding of the basic laws of physics and astronomy. Astrology, thus, remains the province of the con artist, the uneducated, or the feeble-minded. Tim Endham from Australian Skeptics says it was amusing to find a Sri Lankan news site upholding those high standards of journalism we often talk about by claiming that it wasn't unusual to find scientists who believe in astrology, especially in their personal lives.
Astrology's been around for thousands of years, and it has its moments of fame and glory and then disappears for a bit in popularity, then comes back again.
But it's based on a lie.
It is, totally. A total lie. It's been an effective one, obviously. A total misunderstanding of astronomy and of gravity and interplanetary bodies or interstellar bodies' attraction to each other, etc.
Total misunderstanding.
But the whole concept is total misunderstanding of science, total misunderstanding of psychology, total misunderstanding of character studies. It's just a completely superficial on every level. It's one of those things where skeptics can say with pretty good confidence that is 100% bunk, but nonetheless, people still come out and say it. And one of the interesting things I was reading actually in a Sri Lankan newspaper or online newspaper of all sorts was suggesting that, you'll find that even Nobel Prize winners want to get their horoscope done and to find out whether it's a good day to receive their award, which I find a bit of a strong statement. It was also
but
suggesting that
true. They're just because you're a Nobel laureate doesn't necessarily mean you're very bright in other areas.
That's right, and we have published articles on that very thing.
Yeah, the Nobel syndrome or something, isn't it?
It is, yeah, and you would expect a higher standard. I mean, everyone's prone to beliefs, but you would expect a higher standard of people with a Nobel Prize. But as suggestions that people might be sceptical of astrology, as you and I, are based on, one, because we weren't introduced to it properly, we haven't been properly educated on it, or because we're just haters and hate astrology. And that I'd like to point out that that's not true. You and probably a lot of your listeners, and I have certainly have looked into astrology, looked at the explanations for it, looked into the evidence that's been put forward over the years, and whatever culture, astrology varies from place to place, and are not necessarily haters, but I mean, way back when in my youth, I did my own astrological chart, proper one,
really?
Place of birth, time of birth. I had all my ephemeris, I'm not quite sure how you pronounce that word, but all the little,
ephemeris,
thank you, what was in the sky at a certain time when I was born. And of course, understanding exactly when you were born was not very precise when a midwife in the middle of the night puts down 4 o'clock. So, rather than 5 past or whatever. But I found I was going to have a career in publishing or travel, and I was going to be wiped out by enemies. So I figured I was going to have one of those newspaper kiosks on a railway station. And the fellow from the next railway station didn't want the competition, so they're going to wipe me out.
No, but Tim, you do have a career in publishing. You're a journalist.
I know. Well, I was obviously influenced by the astrological reading.
That's it.
Yes, I know. Or the fact that I could read and write might have helped me have a career in publishing, and then I could do my own star chart. I don't know.
The simple fact is there are not 12 but 13 constellations in the ecliptic, and so everything's off.
It's off by a whole star sign, because there's Ophiuchus in the middle there, which is the snake, somewhere around Scorpio or something like that. But of course, all the star signs themselves are of different length. I think Scorpio is only about the sun is in Scorpio or on the ecliptic, as you say, for about 7 days. So rather than all these 12 star signs be the same length, that's just totally artificial. Some of them are 30-odd days, some of them are 17, 11, and 9 or something. So the whole structure of the 12-sign zodiac is wrong. And then there is, of course, the precession of the equinox, right, which is shifting the whole background of constellations.
That's totally because the Earth's spin axis is itself pointing in different directions over millennia. It
has a bit of a wobble to it as well.
Like the axis of a top that's spinning.
That's right.
Will move.
Yeah. So over the period of 25,000 years, we will go through the entire set of constellations, and there will be different dates around the time. Now, we've just gone from the original Aries, which was up in the sky, the point when this was being developed by the Babylonians, etc., and that's why most star columns in newspapers start with Aries, just a tradition, but they're actually Aquarians now, as in this is the dawning of the age of Aquarius. Yeah. If you know your hippie musicals.
I do.
You do. We have probably which dates us, Stuart, but never mind. But therefore, in another 2,500 years, 2,000 years, all these things will change. Precession of the equinox, the wobble of the axis of the Earth, the extra star signs that we find it difficult to add another one in because 13 is hard to divide, the fact that all these star signs are of different lengths, and of course there's the basic physics that there is no way that star signs and things, which are phony structures in themselves because they're not on one plane. Elements of a star sign of a constellation can be light years apart from each other. When you look at it from the side, it looks nothing like it does from where we are. But apart from that, and the fact that also astrological character predictions are totally shonky and can be applied to anybody. So if you add all those things up together, astrology is bunk. Doesn't stop people believing it.
Mind you, the idea of having wings being built like a horse sort of does appeal to me, I must admit. The immortal Dr. Sheldon Cooper from Big Bang Theory probably said it best when talking about clairvoyance and astrology and that kind of thing. There's no scientific evidence to support it. It means that fortune telling and all that sort of guff is a total fraud. The profession's a swindle and its livelihood is dependent on the gullibility of stupid people.
How cruel, but that's Sheldon for you. I understand people's beliefs and why some people believe, and we've covered this in the magazine, etc. And there's all sorts of reasons why people might believe one thing or another. A lot of it's politics, a lot of it's sort of fear, a lot of it's desire for a more interesting life, all sorts of different reasons, and often the different pseudosciences have different reasons why people believe them. They're not all the same. Religion crops up, of course, all sorts of things, spirituality, everything crops up. But the actual study of why people believe is just as interesting almost as the beliefs themselves.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.